Hi everyone, I'm Pravar Jain from KONUS Center, and today, on behalf of my co-authors, I'll be sharing our work done at exploring the effects of olfactory stimuli on the occurrence of visually induced motion sickness in head-mounted display-based virtual reality experiences. In recent years, developments in the field of VR have provided an expanding number of consumers with the ability to explore and interact with increasingly immersive virtual environments. However, despite continued improvements in the capabilities of these systems, majority of existing VR technologies still share several underlying issues that can have detrimental effects on users' experience. One of the core issues faced by these VR systems is the occurrence of visually induced motion sickness, a common side effect caused due to a perceptual conflict between the somatosensory, visual, and vestibular senses. Its symptoms include pallor, cold sweats, dizziness, nausea, and vomiting. VIMS is influenced by many factors, including visual resolution, refresh rate, field of view, the time lag between different events, as well as an individual's physiological conditions. Over the years, several remedies involving the use of motion platforms, rest frames, controlled breathing techniques, acupressure, as well as habituation have been employed, but have shown limited success at reducing VIMS. These methods relied on utilizing modalities that are typically engaged within traditional VR experiences. Taking cues from aromatherapy, which has been practiced as a holistic treatment to improve physical and cognitive health, we wondered if an additional stimuli via a modality that is not typically engaged in VR, such as olfaction, could have an impact on VIMS. While we came across literature that demonstrated the effects of olfaction on nausea, there was a lack of studies that investigated its effects on VIMS at large. So we set out to explore this avenue and prototyped a system that affords one, the delivery of controlled olfactory stimuli, and two, allows for the calibration to an individual's preferences in order to enable a systematic evaluation in this formative study. Our system comprised of a Samsung Gear head-mounted display with a Galaxy Note 5 mobile running a popular roller coaster VR simulation called Relix VR. Here, via pulse width modulation, a BLE-enabled microcontroller manipulates throughput of a mini air pump that is connected to a scent chamber with peppermint oil. The air saturated with peppermint is then delivered to the user via medical-grade polyurethane tubes. We kickstarted by conducting a couple of preliminary studies. First, to benchmark the effects of olfaction on VIMS, there was an inherent need to induce it. So, with a small group of participants, we conducted a study comprising of two conditions where participants experienced 1 and 3 rounds of the roller coaster simulation without olfaction, and in a randomized manner. A considerable increase in the simulator sickness scores indicated that the configuration with 3 rounds was better suited at inducing VIMS. We then conducted a study with 3 intensities of olfactory stimuli. Scores on the olfactory intensity rating scale indicated that the condition with 50% duty cycle was perceived to be moderate and most suited. Based on the learnings from the pre-studies, for our main study, we recruited participants who experienced 3 configurations, each comprising of 3 rounds of the roller coaster simulation with varying extents of olfaction, with the stimuli being delivered at medium intensity. Participants experienced these configurations in a randomized manner and with 24-hour intervals in between. Questionnaires and scales such as the Simulator Sickness, Fast Motion Sickness, Olfactory Intensity Rating, Chemical Odor Sensitivity, and others were used both before and after the trials for self-reporting on parameters associated with VIMS and olfaction. Here are the results of our study. In the interest of time, I will not get into the statistics, but please do refer to our paper for more details. Do note that while conducting the studies, 3 participants who experienced all 3 configurations stopped prematurely due to severe VIMS. Hence, we analyzed the data both including as well as excluding them. Right, so SSQ is a weighted combination of 3 components: nausea, oculomotor, and disorientation subfactors. We observed a downward trend in nausea with olfaction, and more importantly, there was no increase in nausea, which validates our initial selection of the intensity of the olfactory stimuli. Olfaction had a limited impact on the oculomotor factors, since these symptoms are heavily dependent on factors like resolution, refresh rate, and field of view. A reduction in disorientation and a noteworthy reduction in SSQ at large was observed, especially with the medium olfaction configuration. Moving to the other scales, a high correlation was observed between the FMS and the SSQ, thus confirming the reduction in VIMS in the medium olfaction configuration. As expected, this configuration was rated to be perceived as of moderate intensity, and the participants did not display any extreme odor sensitivity or insensitivity. All the participants found peppermint to be calming, pleasant, and refreshing. To summarize, irrespective of the intensity of the peppermint olfactory stimuli, we observed some degree of reduction in the severity of VIMS symptoms. The most significant reduction, though, was observed with the configuration medium olfaction, suggesting that there is an optimal olfactory intensity range. Also, with peppermint being rated as a pleasurable olfactory stimulus, We speculate that the alteration in attention, arousal, and perception could potentially have led to the reduction in VIMS symptoms. Apart from limitations, through the course of this work, we came across a range of potential opportunities with considerations on how olfactory stimuli may be employed in VR of the future. Firstly, olfaction is subjective. It requires calibration to an individual such that it is sufficiently intense to be perceived, as well as sufficiently mild to not evoke any intensity related nausea. Now, while in this work, the experience required no active interaction, future research may explore how olfaction can be adapted to address VIMS in broader sets of VR scenarios, those with varying degrees of active and passive interaction, frequency of motion, etc. Lastly, apart from intensity, there may be several other olfactory parameters that could reduce VIMS. These include pleasantness, contextual congruency of the scent to the visuals, the olfaction release patterns, and their impact on engagement and immersion, among many others. Hence, we believe overlaying of olfactory stimuli to reduce VIMS presents itself as both a limitation as well as an opportunity while designing VR experiences. With that, I would like to end my talk and encourage posting of any questions that you may have. Thank you.